So I hope you are fine. Sorry guys, I was unable to create the video for 23rd January's problem of the day. So I'm gonna explain you today. So let's go to the problem. So the problem is pretty easy. It's a either it's a medium type of a problem, and topics are uh, array, depth first search, breadth first search, union, find, matrix, counting, blah blah. But this is a similar kind of a problem. The problem is we have given a matrix in which there are lots of computer, right? So matrix is of m cross n, and we have given that if the cell contains 1, that means there is a computer, and if the cell contains 0, means there is no server or a computer, right? So two servers are said to be communicating if they are in a same row or a column, right? So these two servers are not communicating, so the answer is 0. So we have to return the number of servers that are communicating with any other server, right? So in this case we have these two servers communicating and these two servers communicating, so overall three servers are communicating with each other. Three servers are communicating, that's all, nothing else, right? These two servers are communicating, these two servers are communicating. This cannot be communicated with because there is no server in its row or column. So answer is 4, because total 4 number of servers are communicating. So how to solve this problem? How can we think about it, right? So basically we have to check, right? So right, we have to think about a most basic thing which we can do. We have to check, like we have to check if there is any computer in row column, right? So for that, this is a native approach, right? So what we can do, we can iterate over this and check if there is any computer in its row or in its column, right? If it is the case, then we will add this computer, right? So what is the time complexity? Time complexity is for iterating over all the cells. The time complexity is iterating over all the cells. The time complexity will be of m cross n, of course, because the cell is of m cross n. And for each computer, right, for iterating through this through the row and column, it will be m plus n. So this is the total time complexity, which is disastrous. Let's say, so we can solve this, but no, we don't want to solve this in this type. Space complexity is of course 1, because we don't have to store anything, right? So what we can we optimize this approach? Think about it, guys. Uh, Before, like, we don't want to iterate through the every row, and we don't want to iterate through the row and column each time. Every time we are checking any cell, right? So what we can do, I have an approach, right? What I am doing is I am iterating through each cell, right? So my ROCH, my approach, right? Iterating THROUGS through each cell, iterating through each cell, and count the number of servers in the cell. Okay, so what I'm doing is I am iterating through each cell and I'm counting the number of servers in the cell, right? Good. Second, if num servers is greater than 1, so I will add num servers in answer. Also, I will add the row in server rows array. I will append. Good. Okay. Where is this rows? Okay, I have to not array but set, because we have to search, right? And inside searching is in O1. So we will get rows equals to set, right? Okay, leave it now. Third, then we will iterate throughs through each column and count the servers, right? If servers row is in server rows, right? That means we have counted that server earlier, so we don't want to count it. So we will count it in temp 2, either else we will count the server in temp 1. So what I'm doing is, after iterating through each column, each cell, each row, I will iterate through each column, right? And check that if that column contain server, and if that column contains server, then I will check that do I iterate through that row, do that server is getting added by that row. So if it is the case, I will increase the temp 2. That means server is present, but I don't want to add in my answer. It's just the case for checking that, okay, in this case, right? So let's see. Oh, so so that means we don't want to count it in the answer, but it is serving the purpose that there may be a server in the same column which is not counted in the rows, right? So that will get added in the answer. So for if temp 1 plus temp 2 is greater than 1, that means the server in this column is communicating, but I don't want to add the servers in temp 2 because it is getting added in the row wala iteration, right? So add temp 1 in answer. That's all I am to do. So what I am doing is, I am iterating through the matrix 2 times, and that's it, nothing else. So the time complexity, because this thing for searching in server row, this will take only O1 time complexity, because we are adding this set. So time complexity is O of m cross n. So I am reducing this time complexity. I have reduced and increasing the space complexity is O of m, because adding the servers. So that's it, guys. So this is the code, this is the answer. This temp 1 is nothing but num servers, right? Num servers 0, rows is nothing but server rows. So okay, let's first replace the temp with the num servers, and control Z, control copy, rows with nothing but server rows. Okay, good. So this is iterating through the row, right? If the grid has 1, that means a server, num server greater than 1. If num server is greater than 1, I will add in the answer, nothing. Okay, This is temp 1, this is temp 1, this is temp 1, this is temp 1, this is the point number 3 and 4. I am iterating through each column and checking if in the server rows. So increasing temp 2 as temp 1. If this is the case, returning the answer, running the code, this should get solved, but not getting solved. Let's check what I've done wrong. What I've done wrong. What I have done wrong. So I'm creating the answer variable. I'm creating the num server. Mn server row is set. I0 J0 num server equals to 0 if num server would be greater than 1, I plus 1 answer plus num servers. Okay. I was doing some experiment, guys, sorry, but yeah, this is getting solved. I hope you understand this problem. This is getting solved with pretty good time complexity. See, guys, this is the most optimized thing we can do. Either we are iterating through the matrix 2 times. We can do it using 1 time, but it's okay. I mean, you have to worry about this thing, not the constant, right? If you are getting a solution which is solving your problem in a, this is an time of n time of kind of a time complexity, because there are total m cross n elements, right? So if we consider m cross n is equals to k, so this is a time complexity of O of k, right? Which is a pretty good kind of time complexity. See, this is just 250 cross 250, which is good. I mean, very good. Okay, leave it. I mean, leave it. I hope you I hope you understand my approach. I hope I'm able to provide you everything. Provide you my understanding. Thank you for your time. Thank you.